Hey College Algebra class, this is section 2.2. We're going to be learning about graphing circles and also writing the center radius form of a circle. And I put this in here. We are actually not going to do the general form of a circle. We're just going to focus on the center radius form. So if you come across any of your homework problems that I give to you that ask you to put into center radius and general form, don't worry about the general form, just put in center radius. So we will not be using the general form. We're also going to be looking at an application problem to these circles. Something like you would probably see on the ACT or an SAT test. Okay, circle radius form. By definition, a circle is a set of all points in a plane that lie in a given distance from a given point. The given distance is the radius of the circle, and the given point is the center. So, center radius form of an equation of a circle. Let's see. This is what you have. A circle with center HK and radius R has the equation this right here. So H goes along with our x value, like our x coordinate, and then K goes along with the y value in our coordinate. And then our R is the radius of that circle. Okay, so this right here, a circle with a center 0, 0, and radius r has the equation this right here, x squared plus y squared equals r squared. Now on this it says find the center radius form of the equation of each circle described. So we have a circle centered at 1, -2 with radius 3. So plug in this for H, this for K, and then this for your R, and you've got the center radius form. So here we go. I'm going to plug in x minus 1 squared plus y, then minus -2, you get a positive 2 squared equals 3 squared, so 9. And you're done. That is the center radius form of the circle. There's no squaring anything or combining any terms. You're done at this point. Okay, and then B, centered at 0, 0, radius 2. So remember, our HK values are 0, 0, so we're going to get x squared plus y squared is equal to 2 squared, which equals 4. And that's it. We're done. Okay, now we're going to graph. We're going to go the other way. We're going to figure out what our center point is, and then we're going to figure out what our radius is from our equation that we have. So our center here, we have 1, and then there's a 2, but you gotta watch out for the plus and minus signs that we have. If it's negative, our value for our center is going to be a positive number. If it's positive, it's going to be negative. So there's our center. And then our radius comes from here. Take the square root of that number, which is 3, and that is our radius. So we're going to have our center at 1, -2. There is our center. And then we're going to go out a radius of 3. So go out 1, 2, 3. Go out 3 all around your center, just like this, and then kind of draw your circle from it. Okay. There you have it. There is your circle centered at 1, -2 with a radius of 3. And then we are asked to graph x squared plus y squared equals 4. So our center is at 0, 0, and our radius is the square root of this number, so 2. And let's go up 2, over 2, down 2, left 2. And draw our circle. And that's it. That's all there is to drawing circles that are in the center radius form. Okay, general form of the equation of a circle will look something like this, but like I said, we are not actually going to go over this. Okay? Not going to focus on that very much. General form of an equation of a circle, we're going to consider these possibilities. There are 3 possibilities for the graph based on the value of m. So if our m value right here is less than 0, then our radius is going to be found like this. I'm going to take the square root of our m, and that is our radius for our graph of our circle. And then if our m is equal to 0, it's just a single point on the graph located at hk. And then if our value of m is less than 0, then this is a non-existent graph, that we don't have a graph at all. Now, this is our last example actually that we're going to look at. Pretty short and sweet lesson here. We are going to look at locating the epicenter of an earthquake. If we know the location of 3 receiving stations, and then the epicenter of, or how far away they recorded the distances from each of those receiving stations. So here we go. It says if 3 receiving stations at 1, 4, -6, 0, 5, -2 record distances to an earthquake's epicenter of 4 units, 5 units, and 10 units respectively, show algebraically that the epicenter lies at -3, 4. Okay, so what we're going to do is we're going to determine the equation for each circle, then substitute in this -3, 4 and for our x and y values to see if the point lies on all 3 of our graphs. So let's find this one. We're going to find station A. Going to figure out our radius in our circle for this one, or find our equation. So it's x minus 1, because we're using this one right here, and then plus, oh, forgot to square it, plus y minus 4 squared equals, then using this right here, 4 units. That's the radius how far away they felt the earthquake from. This is the epicenter. Okay, so that's going to give us 4 squared, which is 16. So there is the equation for station A. Let's go ahead and find station B and C also. Then we'll substitute in -3, 4 in for each one of these. So here we go. Going to use -6, 0, and then 5 units to help us find our radius. So x -6, and then 0 for our h, or no, our k. So that just becomes y squared equals, then 5 squared, so 25. Now station C. We're going to use this one and this right here to help us find our equation. So 5, so x minus 5 squared plus y minus -2, so plus 2 squared equals 10 squared, so 100. Okay, I'm going to go ahead and on this next slide, I'm going to plug in into each of our equations this point right here, -3, 4, and see if it satisfies each of our equations, meaning both of our equations are equal on the same side. If both of our equations are equal on the same side, and all of them, then this -4, 3 is the epicenter. Okay? So let's do it. I'm going to write this equation again. Okay, plug in -3, 4, no, oops. Plug in 4. Well, we get 0 here, and we get -4 squared here, so 16 equals 16. Checks out here. Let's do station B. So -3 plus 6 squared plus 4 squared equals 25. Well, this gives me 9 plus 16, which does equal 25. So that one checks out too. And then the last one, -3 minus 5, square that. And the plus 4 plus 2, square that, equals 100. Well, this is 64. This is 36, which does equal 100. So there we go. We just checked that all 3 of these equations have a point in common, -3, 4. So this does mean that negative 3, 4 is the epicenter. Okay, and if you like to see a picture of this, all three of these graphs graphed together, here you go. I'll show it to you. There it is. And see this right here? Oh, bad idea. This right here, negative 3, 4, it lies on all three of those circles that are graphed, which were the equations that we figured out from the application problem given to us. So there you have it. I'm done with this lesson for tonight, and I hope you'll have a good night, and I'll see you in class. Goodbye, everybody.